In this video, I'm going to be looking at hydrohalogenation. So let's dissect this word. We have halogen and we have hydro. So this means we have hydrogen bonded to a halogen, such as chlorine, bromine, iodine, or even fluorine. And this compound is going to be added to some unsaturated organic compound. So hydrohalogenation is the addition of a hydrogen halide. That's what we call it. When we just have hydrogen bonded to a halogen, we call it a hydrogen halide. And this is going to be added to an alkene. We have a hydrogen halide bonded to an alkene. So with this reaction, we have certain reaction conditions. Number one, they say anhydrous hydrogen halide needs to be used. Basically, all that this means is that your hydrogen halide should not have water contained in its crystal lattice. That's all. Okay, this is just for interest sake. You don't need to know it off by heart. As mentioned in the previous video, we are only interested in catalyst, heat, or sunlight. Okay, so anhydrous halogen halide of some sort needs to be used. The dry hydrogen halide is going to be directly added to the alkene. And they give an explanation of this. Okay, so they say this is to prevent bonding with an OH group. So they're just explaining here, if this hydrogen halide was hydrated, instead of having hydrohalogenation, we would have hydration taking place. But grade 12s, you don't need to know this off by heart. It's just for interest sake. The general equation for this reaction is an alkene reacts with a hydrogen halide to form a haloalkane. And remember, there's no reaction conditions that you have to write down. So for example, we have ethene once again. The double bond is going to be broken. The bond between the hydrogen and the halogen, in this case we have hydrogen bromide, okay, because it's hydrogen bonded to bromine. That's going to be broken. And attached on the one side to the one carbon, we're going to have the hydrogen, and to the other carbon on the other side we are going to have bromine attached, and then we will have bromoethane forming. So again, we go from an unsaturated organic compound to a saturated compound, and therefore this is a type of addition reaction. Okay, and it's as simple as that. There's really nothing more to it. Here's another example from your textbook. Fortunately, they've labeled the propene correctly this time. So here they say our propene is going to react again with hydrogen bromide. So this bond is going to break. And then over here, we are going to have our our hydrogen attached. On the other side, our bromine might attach. I'm going to draw it up here. But something that's very important with this reaction is that, okay, now this is very important. Our hydrogen could attach to the first carbon, or it could attach to the second carbon. Our bromine could attach to the first carbon or to the second carbon. And this is how you are going to know which carbon it attaches to. We are going to be making use of a rule. Specifically, we are going to be using Markovnikov's rule. Now, what Markovnikov's rule says is that if hydrogen has a choice, it will always attach to the carbon. So the hydrogen is going to attach to the carbon that already has more or the most hydrogens attached to it. So look, we could have our hydrogen attaching to the first carbon, or it could attach to the second carbon. Our hydrogen, since our first carbon here has two carbons already attached to it, so let's look at it like this. Here's our first carbon, here's our second carbon. The first carbon has two hydrogen atoms attached to it. The second one has one hydrogen attached to it. Since our hydrogen has a choice, it is going to go where the most hydrogens are already attached. Therefore, we say the main product that is going to be formed in this reaction is going to be 2-bromopropane with our hydrogen attached to the first carbon. And then the byproduct that's going to be formed, okay, our secondary product, is going to be 1-bromopropane where our hydrogen attaches to the second carbon. So you're going to have a major product. Another name for the main product is a major product, and we're going to have a minor product. The major product is the favored one according to Markovnikov's rule. And to remember this, you need to think of the hydrogen atoms as human beings. Okay, now let's say that you are a stranger at a new school, and this is normal, I think. Let's say you enter a room and you see in the room that there are boys and there are girls, and you are a girl. Normally, not all of the time, but a lot of the time, you're going to find that you, being a girl, would rather go to the group where there are more girls because you feel like you can fit in better. That is what our hydrogen atom is doing here. Or let's use a different example. Let's say that you go to a family gathering, right? And there are all the aunties and the grandmas and grandpas sitting together, and we have the little kiddies sitting together and the teenage group sitting together. Now you have a choice. You can go sit with the aunties and uncles, or you can go sit with the grannies, or you can go and sit with the toddlers. If you are a teenager, chances are you're going to sit with the teenagers as well, because that is where you're going to fit in best. That is basically what our hydrogen is doing here. It goes where all the other hydrogens are instead of over here, because it's sort of going to fit in better over there. That's how you're going to remember Markovnikov's rule. Now, what's nice about your syllabus is they say you only need to know how to form the major product. So you're not going to have to write down both of these. You're only going to write down this first reaction that takes place. So if we scroll down, it's exactly the same reaction. And here we actually have Markovnikov's rule written down, so you can read through it. Okay. In this case, if I asked you in a test, if I told you propene reacts with hydrogen, here now they've introduced chloride. Okay, so we have hydrogen chloride. Now ask you what's going to form. You're going to say, okay, this bond is going to break. We're then going to have one bond available there and one, electron available for bonding there. This is also going to break. Now you need to decide, where's the hydrogen going to go? It can go to the first or the second carbon. Hydrogen wants to go where there are the most hydrogens. Therefore, hydrogen will attach there. And our chlorine will go, where it has space. So our chlorine is going to go there. And therefore, we're going to have 2-bromo, not bromo, chloro. So this here should be a Cl. Be careful of this textbook, guys. So this should be 2-chloropropane forming, and you only need to write down the main or major, sometimes they call it the major product. Okay, so hydrohalogenation, we have a hydrogen bonded to a halogen. It's going to react with some unsaturated hydrocarbon to form some saturated compound, specifically a saturated haloalkane. There you go.